Hello everyone. Today we are going to learn how to use digital image correlation in MATLAB. First of all, let's go to Google Chrome and type digital image correlation MATLAB. The first link here is from MATLAB Central, so this is the correct one, and then go to your right side and just download the zip file and just save it wherever you feel it is, wherever your downloads get saved, or where your lab related data is saved. In my case, I've already downloaded it, and it is here in my folder. This is the folder actually. See, you can see all the .m files. So it also has a PDF here which explains how to use this particular software, but I feel video would be much more informative. I have copied all the files from there into this folder because this is the place where I save my images of the whole experiment. So next what we'll do is we'll go to MATLAB. We go to MATLAB. Okay, we are here, and then open the folder. Note here, open the folder which contains your .m files, and also the same folder should contain your images. Okay, now this is a pretty long video. It has 1500 images, so let's get started. First is a command called file list generator. This actually helps you create a list of all the photos that you have, all the pictures that you have extracted from the image. You can do it either manually or automatically. It doesn't actually matter what you use. I'll use automatically here. It says open first image. It says open first image, so I'll open the first image, and then it asks me to save the file. Okay, I'll save it. This file is actually the MATLAB version of your list of images. It asked me if I wanted to extract time for the stress strain data, but because my video length is different from my data acquisition speed, I would prefer not to match the times on the stress strain data. Then the next command is grid generator. This command actually helps you create a grid on your video. It asks me to open the base image for grid creation. I'll select the first image. Then a window pops up. This window is actually, it actually looks like this. Yeah. So what I do next is I just go to this window, and then it gives me a menu, right? It gives me a menu for this grid creation. Go here, then I say yes. I need to it asks me if I want to load the old grid. Unless you are repeating your experiment with the same dimensions of the sample, I would suggest to click no here and do it every time. Let's use a rectangular grid for this one. Then it asks me to define the region of interest. Pick single point in the lower left region of the gauge section. Do the same for the upper right. That's what I do. I just select it here and here. So this is the rectangle that I'm concerned about. It's divided into 40 and 40 parts. So now each pixel on the grid has been marked, right? As you can see. Do you want to use this grid? Yes, I do. Okay, then end this command. Okay, now let's go back to MATLAB. Now the next command is called automate image. This is actually a command which will give you a window which looks like this. It is actually processing all the images. Yeah, this is what it looks like. Okay, so as you can see, the green markers are the original position of the markers and the red ones are the new ones. As you can see, the red markers are the original position. The red ones are the original position and green are the new position. Okay, so what we do here is just let MATLAB do its work, and it will take about 5 minutes for it to record the whole thing. So I'll just wait here and wait for it to get completed. Okay, so it's done, and these are all the pixel data points on that video. Now the next step is type displacement. This is a command. So what it asks me to do next is that it asks me to open validx.dat. It's a file format. Then the next step, what it asks me to do is open validY.dat. Okay, so here it asks me to open validY.dat. So I open it, and then we get a window which looks like this. Here we have a lot of options to work on. Let's do a 3D mesh plot of displacement. It then asks me if I want to create a video. It asks me if I want to create a video. Here the number of images is too large, and if I say yes, then it will take a lot of time for it to create the video. That's why what I do is I say no. No. And then this is how it works out. It is actually compiling all the data that it has on that rectangle, and then is mapping out the displacement of each point on that rectangle. Let's insert a legend. Okay, as you can see, the displacement is increasing here. So we can easily say that the blue side is the top of the sample and the red is the bottom. The unexpected peaks are due to the inefficiency of the painting on the sample. those are just disturbances which can be removed once you average out the data. This is one of the ways to work with the data that you get after DIC. Okay, so this is how it looks like, which is not very pretty. So let's do another one. Now I'll cancel this, and what we do next is okay. Now what we do next is we import valid y dot dat. This is the y displacement of all the data points that we have. Okay. The whole file is saved here. Let's consider the first and last point here. So first point is equal to answer first row on columns, and last point is equal to answer 40th row. 40th row is because we have table of values. As you can see, the pattern is repeating after every 8 points, so let's consider 8. Okay, now elongation is equal to first point, last point minus first point, right? Okay, now strain okay, elongation is this, and now let's do elongation is equal to elongation minus elongation 1. Okay, so this is the total elongation in terms of this. This is the total absolute elongation. Now let's consider the gauge length. Strain is equal to elongation by first last point 11 minus first point 11. Okay, this is the strain. Now let's plot the strain. This is it. This is okay. Let's add. End result is this. This is the plot of strain on the left side of the whole grid. Similarly, you can do at different points on the grid, and you'll get different values of strain depending on where the fracture is. Okay, thank you.